Hello friends, welcome back to another video tutorial on SolidWorks. Today we are going to create a 3D model of a 3D assembly of steam stop valve. Uh, Let me show you the drawing. This is the drawing of the steam stop valve, and I have taken this drawing from P.S. Gill machine drawing book, and this is one of the most difficult drawings in that book, considering this is a assembly and there is no isometric views or anything given here. And you can see that there are a lot of dimensions, and a lot of dimensions are also missing here. Okay, and on above of all that, this line here, you can see assume proportionately any dimensions not given. Now this here is make a lot of things difficult, this line here, because a lot of dimensions in this drawing are missing, like the thickness of this, okay, this housing here, and even the part names were not given in this drawing. So this is actually a very difficult drawing if you ask me. And let me tell you, you cannot in this drawing, if you are a beginner, you cannot even understand that where a part has started, where it has ended, and what is this hatching here, okay, about these M18 screws, okay, studs, sorry, the hex nuts, everything, and this bridge here. There are a lot of details here, and if you ask me, this is one of the most difficult drawings. So in this video we are going to model it completely in SolidWorks. Okay, we will be using all the dimensions given here. If any dimension by chance is missing, we are going to assume it proportionately as said here. Okay, so this is important now. So let's start with our modeling. Keep in mind that there are many parts, and there are many approaches to it. But you cannot just model all the parts differently. Like you can, if you want to model this housing differently and this cover here differently, then this is going to be very difficult for you. Okay. You have to keep every dimension in mind, and this is going to be done totally in assembly if you ask me. uh, there are two types of modeling approach, like bottom up and top down, and in this case I'm going to use top down design approach. I will make a video later explaining what is top down design approach and what is bottom up. So let's start with our drawing. I will start SolidWorks in assembly. Okay, now insert component, new part. Okay, now let's name this part housing. Okay, let me tell you something. This part here, you can see, okay, this part here is the housing. Okay, this part here, you how to differentiate between two different parts? Notice this hatching. Okay, you can see that this hatching is in this direction and this hatching is in this direction, totally mirrored to each other. That means these parts are different to each other. Okay, this is the same part. Okay, this is the same part, but keep in mind that this hatching can be repeated here also. These parts are not same. You have to also keep in mind the scale between the hatching. Okay, these kind of things you have to always keep in mind. Okay, so let's start. One more thing, you can download this a drawing from my blog or from our Facebook page, or you can get it from our WhatsApp group or Telegram group. I have taken a printout of this drawing, okay, so that I don't have to open it again and again. Okay, let's open SolidWorks. Now Let's open this part. Front plane, sketch. Okay, let's first draw a center line like this. Okay, the center lines are very important here. So the first thing here in this drawing, you have to always keep in mind where to start. This is the most common problem, like should I start with this hand wheel here, or this spindle, or this bridge, or these nuts? Where should I start? So most of these time we start from bottom. Okay, like the first part you can see which has the most dimensions, and you can use as a reference. So this housing has a lot of dimensions. You can see this is one big part, and it has nearly it is nearly has reference with all the dimension with all of other parts. You can see that the dimensions from here 175 to 120, then 112, 34. Okay, every single dimension here is somehow every single part is referenced with this housing. So we will start with this housing. Okay, so this is the center line, and first I will draw this here, this flange here. Okay, then I will make my way to all of these. Keep in mind that this center line here, this is important here. Okay, this center line has a dimension of 175 mm. Okay, let me show you. So you have to keep this in mind also, all of these things. So let's start. I will draw a line like this. Okay, now the outer diameter here is 226. So let's dimension it. Okay, you might be wondering how I converted this to diameter dimension. If you have a center line here, okay, click on smart dimension and select this line or this point, and then select this center line. And now when you move your mouse cursor to the right side, it will convert to the diameter dimension. Okay, double the dimension. You cannot do that with two center lines. Like you selected two center line, you cannot do that. It has to be done with, you can even see that there is a D written here. You can only do this with the end point, a line, and a center line. Okay, the thickness of this flange is 24 mm. Let me show you. Okay, the inner dia, let's draw a line for inner dia. The inner dia is 96 mm. Okay, let me show you this dia here. Okay, now before moving anywhere else, I will draw a center line for this here. Okay, this 175 here. Let's just draw a horizontal center line like this here. Okay, keep in mind that you don't want to double this. This is only 175 here. And one more thing here, let me tell you the positions of these dimensions. I will try to position them exactly where they are in this drawing. Like 175 is here, so I will try to dimension it here. So when we have to check the dimension, any missing dimension, anything, we can check it easily. Okay, let's open our drawing again. Now we have to draw this here. Okay, but there is no dimension given here for this. Okay, there is no dimension given here. Also let me show you, we don't have the distance from this point to this point, but we have a dimension total 120 here, and 120 minus 18, 28, 24, you get the dimension here. Okay, so that's why we needed 175 here. Okay, so let's draw a similar flange here. Okay, like this. So the dimension here is 120 minus 18 minus 28. Okay, and this is 24. Okay, now the diameter here. Okay, what is the diameter for this? Okay, you can see that this diameter is exactly as the cover, the part of the cover above it. Okay, and the part of cover has a diameter of 250. Okay, so the diameter here is 250. I will select center line first. This line here, 250 mm. Okay, I'm explaining every single dimension here. Okay, and keep in mind the positions. These are very important. Okay, the internal diameter here. Okay, this is also important here. You can see 132 mm. Okay, so let's make it 132. Let's make this center line a little upward. Okay, now let's check this again. You can see that there is a line directly. Okay, this line is at some angle, but the angle is not given. We will have to assume it proportionately as written below. Okay, there are many ways to do it. Keep in mind that this part has a draft here, something like that, just like this, but this cannot be as the same angle as this. Okay, so let's draw this part here, this line, something like this. Okay, and there is a radius then, something like this. Okay, let me show you. So what I did, I just created this shape, something like this. Okay, here I have not added this fillet. Okay, here this is not very important right now. Important are these dimensions. Okay, and one more thing here you have to keep in mind, the 5 here is flat. Okay, and I have made it round, so let's make it flat. I will just trim it. Okay, the internal diameter here is 115 mm. You can see, so let's make it 115. Okay, the position here, the position for this. Okay, there are many ways to position it. Okay, you can see that there is a reference here 175 and 96 here. Okay, so you can use this here. Okay, don't use this dimension here 32, because this has to do with this valve seat here. You can see this part is the valve seat, this is the valve, so this 32 is corresponding to this. You cannot use these dimension for this this housing here. Okay, So let's use this dimension here, this 96 here. Okay, so let's go to SolidWorks, select this here, select this line here. Let's make it 96. Okay, now this 96 is here. The thickness here matters also. You can see that the thickness here is 24 mm, but this looks thicker than this here. So this has a little smaller, and you can see that 96 and 132. The thickness here is somewhat corresponding to this thickness. So you can see that 132 minus 96 is 36, and 36 by 2 is 18. So the thickness here is 18 mm. Okay, so let's we will make it 18 later. We have to first figure out other dimensions. Let's make this tangent here. Okay, so now let's make this outer area here, these outer lines, like this. Let's make these parallel. There are a lot of times when we have to adjust these. Okay, the thickness here, 32 minus 6. Okay, we have the position here is 96. Okay, let's we have a position here 96. Okay, for the lower we can use this 78 here. Okay, so let's dimension it 78. Okay, there are no more dimensions here we can use except this 5 here. Let's make this 5. Okay, the offset here is 18 mm. Let's make this 18. Okay, now there is no more way to define it, so we have to assume something here. Okay, so let's assume this angle 6 degree. Let's hope everything defines here. Okay, in upper region everything is defined. We have to still work on the lower part. Okay, this angle looks more steep, so let's make it 30 degree. Okay, we don't have the offset 18 mm here. Let's make it 18. Okay, there is a fillet here also, you can see. Let's assume it. Okay, there is a fillet here also, so let's assume this also. Okay, still underdefined. Let's see what we are missing. Okay, there is a radius here also, so let's assume it also. Let's make it 150 if it is possible. No, let's just move this upward. like this. Okay, let's try again. Okay, it is still underdefined and we cannot find more dimensions so that we can define it. Hmm, let's check here. Mhm. There are no more dimensions. Let's assume some dimension here. Okay, this will fix it. Okay. So what I did here, let me show you. This might come to you as something new. So I selected Smart Dimension and right-clicked on this line and selected Find Intersection with this line. And now I selected this and created a 40 mm. Okay. We still have to dimension it, and we can assume it any dimension here. It doesn't matter much here. Okay, let's make it 15. 15 is too much. Let's make it smaller, 12. Okay, let's trim this here. So this is closed contour here, and everything looks okay. So let's go to revolve bow space and revolve it about this. Okay, now again select front plane, sketch. Now we will have to design this part here. Okay, about 175 axis. Let's make this sketch visible. I will draw a rough sketch here. We can dimension it later. Something like this. Let's draw a center line here. The diameter is 226, 132, 96. 226, 96, 132. Okay. The distance from center is 186 and 24. Okay, it is actually still selected with the center line. Okay, this dimension is 186. '24. Okay. This will go all the way in. So let's make it go all the way in here. Let's see the section. It should be in somewhere between this. So I will just use some random dimension here. Let's say 77, so that it doesn't get stay outside. Okay. Revolve it. Okay. Now, okay, this looks good. But there is a cut here. We have to make this cut here also. So select this face. Now this edge and convert entity. Extrude cut. Okay. Let's cut this till here 140. Okay. Okay. So this looks okay here. Okay, there is a you can see there is some gap. Let's try fixing this with delete face on both side. Delete face is a very useful command in these cases. Okay, so we fixed this also. We have created the cut. Now we have to add. Okay, there are 5 studs M18 on 200 PCD on this flange here. Okay, so let's make this. Uh, this will be done using the hole wizard here. Okay, but before we do hole wizard, I will tell you how to use these kind of holes. Okay, how to create. First of all, create all holes at the end of the feature tree. Okay, all holes should be done at the end, not at first. Okay, this comes from my personal experience. Now first, before using directly hole wizard, first create a sketch on the plane. Okay, now draw a circle here. The PCD is pitch circle diameter. Okay, 200. Make this construction. Now draw a center line like this. Make it circular pattern. How many how many studs we have? 5. Okay, and all of these will be on equal spacing. So uh, let's make 5 here. Okay, exit the sketch. Let's name it PCD 200 5 studs. Now go to features, hole wizard, and now there is something here I should tell you. If you are not aware of tool room workshop things, tap pit holes, there M18 means metric 18, and this is a tapping here. There are threads here, so that the through the stud or the bolt here can be tapped. Okay, so there is a actually there are thread cutted internally on this part. So M18 is not actually any standard. If you ask me, I don't know why M18 is used here. The standards most common sizes are M16 and then M20 directly. But let's make M18 here. Here you have to select straight tap. Okay, and here tapped hole. And now here select M18. M18 select the normal M18 here. Don't select 2.0 or 1.5. There are 2 types of pitches, chorus and fine. I am going to use normal here. Okay, in this case it will be chorus if I'm right. Now positions and select this face, and now select these points. Okay, now keep in mind that you don't want to have a through hole here. Just make it up to next, so that it just crosses this flange here. Okay, now in some taps, if you are aware of tool room processes, we actually create a deburring here. Okay, a type of countersunk. Okay, so you can do that here also with far near, but we don't want it here. Okay, about the type of thread here, keep cosmetic thread. Okay, click OK. So you can see that 5 tap holes are created here. Okay, let me show you from top, and you can see that there is a symbol here. Okay, for internal threads. Let's hide this sketch here, and this part here is complete. Let's move to our assembly again. Yes, now let's save this part. On desktop, I will create a folder steam stop valve assembly steam stop valve. Keep in mind that there are type of notation we use like ASM for assembly, PRT for part, DWG or DRW for drawing. Okay, now click save. Now this part housing here is saved internally, but I want to save it externally. Okay, internal parts have a lot of time we have problems with internal parts, so I will just save this as external part. So this is the first part here. Okay, now let me show you the drawing. Now we will create this plate here. Okay, this plate looks easy to draw here if you ask me. Okay, this plate here, so I will draw this now. Okay, let's select insert component, new part. Okay, and the name of this part is cover. Let's name it cover. Okay, here we have some kind of problem. Okay, I can, let me see if we can draw this totally in a separate part. Okay, as a separate part, because if I'm right, this has to be done in uh, in top-down design approach. So let's see if we can model it, if we have enough dimension. I think we have enough dimensions here. Okay, we have enough dimensions. I can just draw it separately. But let's just, for learning purpose, let's draw it here. Okay, I will just edit this part here and select front plane, sketch. Okay, let's show the sketch in our first revolve plane. And if you want to show the dimension, you can actually do that by showing the feature dimensions. Okay, let me do that. Edit part, front plane. Okay, it is not showing any dimension, but it should have shown. Maybe my SolidWorks is broken right now. Let's just hope it doesn't crashes. So we can just do it. This is good enough for us. I will select front plane, sketch. Okay, while editing this cover part. Okay, keep in mind that we always have to take backups of our document if you are working with SolidWorks, because SolidWorks crashes a lot. Okay, too much times. So let's draw this 28, 18. Okay, 250. Let's draw from here. The height here is 28. Okay, something like this. Okay, so keep in mind I have created a coincident relation here. I will just move it here and make this coincident here. Okay, as this is in our drawing, you can see the line here is coincident. Okay, so let's dimension it now. 28. Okay, the diameter here is actually equal to this, so we have no problem here. The diameter for this here is 152. Okay, let's draw a center line here. Okay, the height here is 18. Okay, the internal diameter 60 mm. Okay, the diameter here is 90. We don't need to do 132 mm here because it is actually coincident here. Even if I want to show, it will be a driven dimension. Okay, okay, so 82 from this point to this. Okay, okay, the dimension here, this is gland, 10, 56 here. No, 56 is not here. We don't need to use 56 here. Okay, we still have to find out the dimension here. Okay, there are many ways to do it. Let's find out the best way. There is the gland. Gland will go all the way down. Okay, okay, there is the dimension we can use. There is a 56 and 10. That will make 66. Okay, so let's make this 56 plus, sorry, 10 mm. It was 10 mm. I accidentally used 6. Okay, the diameter here is 90. We have used the 90 here. We still have to use find out the dimension for this here. Okay, we can assume it also, but let's try finding if there is any dimension. Okay, it will be better if we can find any dimension. Okay, I don't think there is any dimension related to this given here, so let's assume it. Let's make it 10 mm. Okay, okay, it should not be coincident. Not here also. Okay, there is a internal diameter here that is 32 mm here. You can see spindle goes all the way till this part here, so it should be 32. Okay, okay, all the dimensions here are done. Let's revolve it. Click OK. Okay, we have created the cover also, but we have to create tabs here. You can see the clearance hole for these bolts and for these studs here. So let's do it. I will open this part. Yes, one more thing I have to tell you. If I will show you the revolve sketch, this is shifted from origin because we are using the assembly origin. Okay, so this will be shifted, but it doesn't matter. The origin doesn't matter. Any reference you can use any point as a reference. Okay, origin is not any, you know, um, any bookmark or something. Yes, in case of a CAM software, you will need to move your part, but that is no trouble here. Okay. So first let's select this part. The PCD was 200 pitch circle diameter. You can see here 200. So I will draw a circle here, 200 mm. Let's make it construction. Draw a line here and 5 times. Okay. Let's name it 200 PCD 5 M18. Okay. Now we have 4 here also. 4 tapping here. These are at there is no dimension given. Let's try to find out. There should be some dimension here. Okay, there is a bridge here. Okay, let's see the dimension here on the bridge. Okay, there is a 106 mm here. Okay, so the distance between these is these are actually 106. Okay, so let's draw a circle here, 106. Let me show you this part again. So there are only 2 studs M18 written here, but there are 4 holes on this bridge. Okay, so let's make 4 M18 tap here. Okay, so I will draw a line here like this and circular sketch pattern 4 times. Okay, now let's make it 106 PCD 4 M18. Okay, sorry, it is M18. Okay, now let's use hole wizard. There is something I have to tell you. You can see that there is dimension written here as there is no dimension given here, but in this case this is a clearance hole for this stud here. Okay, this is not a bolt here, this is a stud. Okay, so let's use this dimension. Okay, let's use this M18 as a reference. I will go to hole here and there is a screw clearances and you can select M18 here. Okay, and in this you can set is as close, select close, but in close it will be 19 mm. Okay, I don't want 19 mm, I want exactly 18. But in machining you will never get it, like in case of you are using drill holes. If you used anything like CNC or EDM wire cut, it will cost a lot. So let's keep it, let's assume it 19 here, and I will create 5 holes here. But wait a second, let me see this again. Okay, this will align perfectly because there is a flange here. Okay, this tab here will automatically align with this, so 19 here is okay. If you made it 18 and there is some machining accuracy, it will have some problem with the alignment due to GD&T, wrong tolerancing. So if you make it like 19 here, you still have a play of 0.5 mm, so that even if these holes shift 0.5 mm, it will still be okay. Okay, if you didn't understand this, just comment about this and I will show you how it works in a different video. Okay. Now for these there are 4 M18, 4 because you can see there are 4 holes here. Okay, 1 2 3 4, but there are only written here like 2 holes 18, these type of things. I will explain it later. For start, let's use this 2 holes diameter 18 here. Okay, the depth here is 25, but 25 is only for the threaded length. Okay, okay, so that stud here only enters 25 mm. There should be a little more than that, so let's say 30 mm. Okay, and the drill will go all the way till 32 if you ask me. Okay, so let's use hole wizard here. I will show you how it works. I will select straight tap, tapped hole. Okay, make it blind. Okay, so you can see that the stud will only mate till 25 mm, so it should be a little larger than that. So let's say 30 mm is the threaded length. Okay, so 30 mm is the thread length, and we want some kind of clearance, so let's make it 32. You can see that it automatically adjusted. So okay, now positions, select this face and create 4 holes here like this. Let's see the section. Okay, this looks good. So we have modeled the second part also, the cover. Let's save it. Yes, I will save the assembly also. Let's hide these sketches. Oh, let's keep it because we don't know what kind of reference we might need in future for other parts. So the next part here is the gland here. You can see this part. And let me tell you something here. You can see that there is a white space here. But that white space doesn't mean that there is some kind of clearance. This part goes all the way till here. Okay. So let's make this part. We will draw this in top-down assembly approach also. So I will select insert component, new part. Let's name this part gland. Let's edit this part, front plane, sketch, section view. Okay, let's select the cover and the revolve. Let's show this sketch also. It will help us a lot. So this part is like this here. Okay, till this. Let's make it vertical. There is a line here like this. Okay, the height from this to this here is 42 and 10 68. Okay, from this to this 42 10, and for the diameter 68. Okay, let's revolve it. Okay, So this part gland is also complete. Okay. Okay, you can see that there is some kind of cavity here, but this is only for your reference. Okay, so that you can see that there is some kind of but there is no gap here. These kind of things happen in a lot of times in drawing. So for example, here you cannot see any hatching here. Okay, so this part here is complete. Next is the we have to decide which part we have to model next. Okay, let's make this valve seat here first, and then we can make this valve easily. Okay. This valve seat, there is not much dimension if you ask me. Let's make this in completely in top-down design approach. Okay. So let's exit this. Right click here, collapse item. Okay. Insert new part. Okay. Let's name it valve seat. I will edit part, front plane, sketch. Okay, let's see this from this point to this. Okay. So it is like this. This part is like something like this. Okay, wait a second. Okay, something like this, but let's dimension it with whatever we have. Okay, the color is 5 mm, but we have already created a relation here, so it is already 5 mm. The height is 6 mm. Okay, the total height is 32. From this to this 32. But there is a relation like this here. Okay. Okay, there is some error. Let's fix it. Okay, so this is already defined here. Okay, nice. So we don't have to assume anything here. This is for beta. The ID is 100 mm. Let's draw a center line first. If you hold down control key, you can cancel the snaps. Like it will not automatically snap anywhere. 100 mm. Okay. Now we have to assume this angle. There is no angle given, so I will just assume 30°. Okay. Let's leave this till here because we don't have much dimension here. This will this angle will be calculated based on the drawing from this valve here. Okay, so let's just leave it like this here. I will just exit the sketch because I cannot estimate how much this is until I have modeled the valve. So let's start with our next part, valve. I'm sorry I have skipped this valve seat here, but we have to figure out more dimensions. And in top-down design approach and in these kind of drawings, there are many times we have to skip one part, and we have to, otherwise we have to create some kind of relation between the dimensions. Okay. So let's draw this valve here now. I will, let's edit this sketch, edit part, front plane sketch. Let's draw a center line. Okay, the valve sheet has something like this here. Okay. Hmm. There is no coincident relation. Let's remove it. The height is 8 mm. Okay. With whatever dimensions we have, I will keep on doing it. I'm not sure if we have, I cannot promise that we have all the dimensions always, but with whatever we have, we will keep on doing our work. Okay. Let's make this parallel with this. Okay. Now this is 8, 32 from this point till this point 32. Okay. And from this center line to this end point it is 100 mm. Okay, so this is a important dimension we got here. The length from this point to this line is 100 mm. Okay. This is nice. Let's draw this here now. It will help us figure out more dimension. Okay, it was inclined. I made a mistake. Okay, the diameter here is 60 mm. From this point to this, okay, this is inside dimension, we don't need it. From this line to this line 32. Okay. We still need more dimensions. This diameter here is not given. We have to assume it. Okay. So there are many times we have to assume a lot of dimensions. Rather than using a diameter dimension, let's assume that the angle here is, let's say, 60 degree. The angle between this line and this, let's say, 60 degree. Okay. Okay, 60 is too much. Let's make it 30. Okay, this looks okay. There is one more mistake I did. It should be like this. .30 and this here is 10 mm. No, but that is not for this here. It is a little larger. It is little larger than this here. So let's say 12 mm. Our ultimate goal is to completely define this. Okay. Mm, from this point till this point 32. Okay, I have already created the 32 mm dimension. Okay, this is coincident on this. Okay, and the diameter here is not given, but it is somewhat on this. So let's assume the diameter here. Okay, 120 looks fine. Okay, let's exit this sketch. Now I will fix this valve here. We have to assume this also. So let's make this here 5 mm. It will be like a chamfer here. But let me check again. Okay, it is not coincident here. Let's remove the collinear relation. Okay, now this 5 here doesn't fits well. Okay, there is no, the step is not here. Okay, something like this. And let's assume this again. Let's make it 115 and make these collinear. Okay, this looks nice here. We actually I assumed a lot of dimensions here, but these are keeping in mind the proportions here. Okay. We are going to only revolve the upper part. I'm not going to revolve the lower part because the geometry here is not as you think it is. Okay. So I will just draw a line here like this and close this sketch here. Let's make this construction and revolved base about this line here. Okay. Now let's open our valve sheet. Let's revolve it also. Okay, you can see that it looks okay here. Now we have to design this part here. Okay. This may look a little, easy, but this is not a easy part here. Okay. The thickness here is let's see the dimensions here. The radius is 42. Okay. The thickness here is not given. Okay, one more thing. The dimension here, you can see 6 into 45 degree. Okay, this is for the chamfer here on this part. So let's update this. We missed it. I missed it last time. So let's fix this here. There are many times even I miss dimensions. We are not some practice is what makes us perfect. Okay, let's revolve it. Let's go back to our assembly. Yes. Edit the sketch. The angle here should be 45 as well. Okay. Let's make it 6 also. Let's edit the sketch in our valve and let's create a this should come on this here. Okay, so in this valve sheet let's show the sketch and create a coincident relation between this line and this point here, and it should be fully defined. Perfect. But it should come out. It is not coming out. So there is something we need to fix. Okay, if I increase this, or let's say decrease this diameter, it should go down. But it is something on and off this here. Okay, and on this valve let's change it to 4 mm, and now let's adjust this 111. Actually this is coincident here, so let's just make this coincident on this here, and okay. Now this is perfect. Nice. Now we have to model the lower part here. Okay, this here. Okay, these are ribs here, 4 ribs, and the thickness here, let's try, let's see if it is mentioned in this drawing anywhere. I cannot see, so let's assume it is 15 mm. Okay, so just let's draw a let's convert this circle here first on this. Okay, select the lower face, sketch, and convert entities. Draw a line here like this. Okay, and offset entities, bidirectional, 7.5. Okay, Now draw a line here also, a horizontal line. Repeat the same process. Base geometry, okay. Let's convert it into construction also. Let's trim the outer portion here, okay. This also, this also. Let's extrude it. Now the extrusion height here is from the 100, it is from this axis it is 100 mm, okay. So I don't know exactly, I will just leave it like this. Let's go to our assembly, okay, and let's edit this let's edit this part here, valves part here, okay, and select front plane, sketch, and select center line, and draw a center line here like this, horizontal, and dimension it 100 mm, okay. So what we did is we created a reference here till 100 mm from this axis. Let's open this part. Select this, extrude, select this vertex, click OK. Now if you look at it carefully, there is a 42 mm radius here. So this means there is a cut here. So let's do it. I will select front plane, sketch, select a center line and draw a center line here. The offset is 4 mm, okay. So let's make it this 4 mm. Now draw a circle here with 42 mm radius, that means 84 dia. But let's convert this dia into radius, okay. Now we have to make a revolve cut. Okay, so this is what basically this geometry is, and if you look at this carefully, you could this is a little difficult to understand, but now you can see it clearly that how it is, okay. Now we have to make a cut here, okay, this cut here for this cavity. This is also a little difficult to imagine, but let me show you how it is done. First select this face top, okay, sketch normal to. Now draw a circle here. Now this circle on the top should have a diameter here equal to this, but there is no dimension here mentioned. So let's assume this is 32, and if I go proportionally, this should be around 28, okay. So let's assume this to be 28 here, okay, 28 mm. But let me tell you something here, okay. This part here, spindle, has to be inserted in this valve here, okay. If so, there should be a slot here cutted here, okay, slot, something like, okay. So let me tell you, there are cutters here like uh, bull cutter and all these kind of cutters that can be used for this process here, okay. So let's draw a let's first convert this face here, okay, and now draw lines here like this and trim, okay. Extruded cut, the extrusion is let me see, 10 mm, okay. So let's make this 10 mm, okay. Now for the lower part, the diameter is 46 and depth is 12 mm. Okay. Now this is easy. Just draw a circle here, 46 mm. Cut. The depth is 12 mm. Let's make it 12 mm. Okay. But we still have to make a cut from this face. Okay. So let's select front plane, sketch, and now select this face. Now carefully, this step is important. Tools, sketch tools, and intersection curves. Okay. Now just close this sketch like this and extruded cut through all. Click OK. Okay, so this is the slot I was talking about, so that spindle can be inserted in this slot. Okay, in this valve. So this part is completed here. Let's save this part. Yes. Let's save these parts also. Okay, I have saved all the parts. Okay, so you can see that these kind of sketches are used in reference a lot. Okay, but these references can sometimes be problem. For example, if you edited this part housing, a lot of dimension associated with these will change. Okay, so for this we have to first lock all the external references. So for example, right click, cover external references and lock all, so that any dimension in this part which is associated with this housing or any part doesn't changes. Let's repeat the same process for all the other parts. This is a very important step here. Okay, this part doesn't have any external references. Okay, let's save our assembly. Okay, so for the next part here now. Next part, let's see. We have done gland. So for the next part, let's we can model this bridge here. Okay, but understanding the geometry here will be a little difficult. Okay, for you. This gland is modeled a little differently. Okay. Okay, we can model this hand wheel. Okay, or we can model this spindle here. Okay, if you ask me, let's model this spindle here. This will give us reference for these here. Okay, so let's model the spindle. I'm not going to use any reference here. Okay, but we are not sure how many dimensions we have. So let's design this also in assembly mode. Okay. Okay, mm, the spindle has a, okay, from this point to this point we have 14 mm. Okay, so let's draw a line here like this, and let's show the sketch. Okay, these are enough. The dimension here is 14, so let's make this 14. Let's draw our center line. This should be a very long center line. This is the longest part. Okay, so let's start with uh, the basic part. This one, the diameter is 32 mm, so let's draw this 32 mm. Okay, uh, this goes from here, okay, till 164. Okay, let's make a center line here. 164, and from 164 to 102 we have thread here. Okay, so let's draw another center line here. 102. There is a square thread here, 40 into 8. Okay, and from this 102 to 28 we have, okay, we have just round road. So let's draw here 28. From 28 till, let's say this is 18, so 18 into twice 36. 36 plus 30, because there is some gap here, so it will be 66. Okay, so from 28 to, we have 36 here. Okay, so let's just we can just simply revolve this row till 28. Okay, because after 28, let me show you, after 28 there is some square part here. You can see square 24, because this has to be key for this hand wheel. Okay, after 36 we have, let me make this here, and after 36 we have again the round road. Okay, so our part is very simple here. Okay, you just have to make a lot of revolves, but the main issue is the dimension for this here. Okay, for this, so let's draw it here. This part here is coincident with this valve. Okay, so let's just create a intersection curve with this face. It should do the trick here. Okay, let's extrude it. Let's extend this till this here. Okay, I don't want this line here. Okay, and we have to assume everything here. Okay, so I will just go with some instincts. 3-point arc, make this tangent here. Okay, the diameter, let's assume 40. Okay, and this let's assume 6. Okay, so we have all the dimensions for this part. Let's model it. Okay, I will just open this as a separate part. Front plane sketch. Let's first rotate the parts. Let's first rotate the features we can rotate. Okay, we can do this all in this sketch also. You just have to close it perfectly. Okay, let's revolve it around this axis. There is a square 24 here on this face. Let me show you. This square 24. Let's make a center point rectangle. We can make all the sides equal. Okay, because this is a square and a simple 24 mm dimension should do the trick here. Extrude till this face up to surface and select this face, click OK. Okay, but there is something we have to keep in mind. Okay, if the hand wheel has a let me show you, has a square cross section, how will we fit it inside this? Okay, let me show you again in this. So the upper diameter, okay, this is wrong here. So let's edit this sketch and make this all construction, because let's not jump guns here. Okay, let's change it to up to vertex, and this is the vertex, and let's create a M24 tapping here. Okay, so just create a 24 mm diameter circle, or just create a circle which is tangent to all the sides of this gear. Okay, let's extrude it till this face, click OK. These kind of problems you will face every day in your life as a mechanical engineer, because let me tell you again, if this was the same cross section here, it would not have the hand wheel could not be inserted, so this should be smaller. This is the basic design flow here. Okay, there is a small dome here. We can just use our dome feature. Where is the dome feature? And create a dome here, 2 mm if you want. This is not compulsory here, this is not important. Okay, now this is the spindle part. Let me save it, because now comes the important part. This square threads here. Okay, square 40 into 8. 40 is the outer diameter, 8 is the pitch. Okay, and these are okay. So there are many ways to do this. Okay, you can use the thread command, but thread command doesn't work with square threads. Okay, so I will just use my way. uh, First select front plane, sketch and normal to, and create a rectangle like this here. Okay, because this is where the thread will be. Now we will use our multi-body capabilities of SolidWorks. I will just leave it like this. Go to front plane again, sketch and create a line from this point till this. Okay, let's make this around the pitch is 8 mm. Okay, so it should be a multiple of 8. So let's say 120 is a multiple of 8. Okay, 120 by 8 will be 15. Okay, now let's exit the sketch, select front plane, sketch, and now draw a square here. It should be 4 mm, because 4 plus 4 will be 8 and 8 plus 32 will be 40. Okay, now exit the sketch, select swept boss base, the sketch 6 as path. Now go to option and specify twist value, revolutions. As you know, this is 120 mm and the pitch is 8 mm, so the revolutions will be 15. Okay, the direction is okay. Click OK. Okay, there is one error we did. Uncheck merge result here. Okay, let's fix a little thing here also. This should not be coincident here. Okay, there should be some gap here like 1 mm, because we want to avoid the zero thickness error. Okay, now select this rectangle we created and extruded cut. Okay, uncheck auto select and select this square thread through all both, flip side to cut, click OK. Okay, now go to insert. I have created the shortcut for combine here, but if you don't have, you can go to insert, feature, combine, and now combine everything here. Okay, let's hide these sketches, we don't need them anymore. Let's save our part. Let's go back to assembly. You can see that there is a this pink helix visible here. This is nothing but rebuild error. It will go automatically when we will reload this part. Okay, so we have modeled the nearly all the parts here. Now we have to work on the, you can see this gland here. Okay, and this hand wheel. Okay, let's first model this hand wheel, but we have to make sure there is no reference of this hand wheel with this bridge here. Okay, so after 102, 28, and after 28 this is 24, 18. Okay, there is no reference, so we can just model it freely. Okay, insert new part, select part 7 and let's name it hand wheel. Open it. Okay, uh, 48 mm. Okay, let's draw a circle 48 mm. The cross section is a square 24. Center rectangle. Let's make all the sides equal. 24 mm. Okay. Now the extrusion height is 36 mm. So let's extrude it mid plane 36 mm. Okay. I am doing this mid plane because in these kind of symmetrical geometries, because as you can see this is symmetrical about this axis, so we can use mid plane. Okay. Now this revolve here 212. Okay, the diameter is 24. Let's select front plane, sketch, create a center line. Now draw a circle 24 mm. The distance is 212, and the center of this circle is coincident on the origin. Okay, let's revolve it. Now this part here, the cross section, you can see that it is like something like a ellipse or something. Okay, something like that. You cannot just imagine from right here, but it looks like a rectangle which has fillet edges or a ellipse. So let's work on it. Okay, I will select right plane, sketch, and let's use the ellipse tool first. (20 into 10). Let's make these vertical, and it should be completely defined. Okay, this looks okay. Let's extrude it up to surface, this surface. Okay, and from surface feature select this face. So let me do it again so you cannot you can get it easily. Normally we have the extrusions are blind from the sketch plane up to some distance, but we have a option like up to surface, and we can extrude these sketches up to some surface. Okay, so I marked this surface here. Okay, and you can also, you can see the first limit, you can change that to a surface also, and in that surface I selected this face. Okay, now click OK, and the number of arms is 6. Okay, so let's pattern it 6 times about this here. Okay, click OK. Okay, so we have modeled the hand wheel. Let's save it. Okay, this is our hand wheel. Let's make this float. Okay, oh no, this face. Where has it gone? Okay, click OK. Now select this face and the lower face. Click OK. So far so good. Select this face and this face. Click OK. Okay, this is okay here. So you can see that this is what I talked about. This can only be inserted if the dia here is lesser than this square cross section, and there should be some thread. So 24 is the maximum possible limit here. Okay, let's save our assembly, and let's open this spindle again. Okay, I want to create some threads here. Okay, there are many ways to create thread. We can just use a swept command, or I can just select the thread here. Okay, and you can select this, but it will create some real thread. Okay, I don't want real threads here because it will consume more memory. I want cosmetic threads. It will show in drawings. It can be used as a whole call out, and these are just perfect for our normal work. Okay, okay, click OK. You can see that the threads are created. Here is our cosmetic thread. Okay, let's go back to our assembly stop valve. Click OK. Save it again. Okay, so for the next part now. Okay, we have only this part left here, this bridge, and these studs and nuts. These are not very important, these studs and nuts. The most important part is this bridge here. Okay, and let me tell you, I have seen some drawings done by many people on YouTube and in some other on some websites, and every single person has interpreted this part wrong. Okay, every single person. Some has this lower bridge. Some people have clamped it here. Some people have clamped it somewhere else, but it is not the case here. Okay, so we have to keep in mind some things here. Let me show you. First thing we have to keep in mind is that this part and this part is different, and there is a tapping here. Okay, this tapping is M8 here. Okay, this is done to this is a common process done in many parts. Let me tell you, a bush is inserted in some parts, many parts, and these tappings are done so that this bush doesn't rotate or come out of this bridge here. Okay, okay, this could have been done and could have been done with press fit also, with higher tolerances, but this is a more better way if you ask me. This is I have done in work in progressive die industry, and this is what exactly nearly every person, every die designer do. Even all the foremans, the die fitter, they use this method. This is very popular here. Okay, so there is a bush inserted. Okay, but keep in mind that this is a whole, this is completely one part. This is not a different part. After this bush has been inserted and this screw is clamped, these two parts acts like a single part. Okay, they will be like, okay, this is a single part, this is not, these are not two parts here. Okay, and one more thing here. Okay, you can see that these lines are dark, but these lines are construction line, grayed out, not continuous but dotted lines. This is because this part of this bridge is downside. Okay, below this bridge here, this part here, and it cannot be seen in this drawing here. Okay, so this is something we have to assume here. Okay, this is something we have to assume, keeping this in mind. Okay, so this is 34 here. we can assume that so this part here is 34 thick, but we can also assume that this part here is also 34 thick, so it will be like 34 plus 34 will be like 68. So 68 will be like it will come like here. Okay, but I don't think that this is desirable. Okay, so let's see what can be done here. Okay, I will go to SolidWorks and let's model our next part, the bridge. Let's open this up. Top plane, sketch. There are not much dimensions here that I need to find out from other parts. I can just model it from this. Okay, so first draw two circles here like this. Draw a center line and create a symmetric relation. Okay, select all these and create a symmetric relation, and make all of these horizontal. Okay, the center distance between these arcs or these holes is 106. Okay, the diameter, the radius here is not mentioned. Okay, it is mentioned here, 20 Okay, so let's use that radius. It will be 40 If I convert this to radius, it will be 40 20 Okay, now the next part is this here. Okay, 80 Okay, so it is something like this. Let me show you. Okay, this is something like this. Let's create a tangent relation between this arc and this line. Okay, now select both of these. This line is tangent to this circle and this arc. This arc is tangent to this. Okay, for the radius, let's assume it to be, let's say 10 10 is small, so let's say 25 Okay, okay, this looks okay. Now select both of these and this center line and mirror entities. Now select all three of these and this center line, create mirror entities. Now the distance is 80 so let's select smart dimension and select this point here and this center line and create a dimension 80 Okay, I don't need all these here. Okay, extrude this 34 Okay, now the most important part. Okay, nearly everybody has got this wrong. Okay, we have actually two bridges here. Okay, and one bridge is at 34. So where should be the other bridge? Okay, you can see that this is 44 this push comes till 44. Okay, so what if this part is actually just 10 below this? This bridge is exactly 10 below this. Okay, because this bush should be completely okay. This bush should be okay, totally inserted inside this bridge. Okay, so that means that explains nearly everything here. Okay, let me just make this here. I will just select this plane. Okay, and reference geometry 10 flip direction. Okay, and let's select sketch I can just select this sketch and convert it and rotate it about this point at 90 degree and uncheck keep relation, click OK. Okay, this was pretty easy. But if you ask me, I need all these relations because sometimes we have to model this, we have to change some things. So I will start making relations here. It will be easier to do that now, to make all these relations. Symmetric, okay. Let's create these relations here, okay. Hold down shift key and select the upper portion of this arc and this, okay. Repeat the same process here. Create a tangent relation. This is important. I missed these relations. Okay, so everything is fully defined. Okay, I did one mistake here. The dimension should be the center to center. Okay, now extrude this part 34 mm again, like this. Okay, so now this is the part, and there are holes 18 mm. Okay, I will just do this with simple hole wizard. Drill sizes 18 mm. Okay, let's select the drill size 18 mm. Hole wizard is an important tool because it tells us the standard sizes of drills also. Okay, let's select this face and I will just use that as a reference. Okay, I cannot do that there, so let's do it here. Concentric, okay. Let's repeat the same process here. Let's make it through all. Okay. Okay, now for the bush. Okay, the diameter of bush is 58 mm. Okay, so let's make a hole here of 58 mm through all. Okay, something like this. Now as you can see, there are two tabs here. Okay, M8, and the dimension here is not given, so I assume that it will be exactly on this here. Okay, but you cannot just create a hole here. So first let's go back to our let's roll back our cut extrude and select this face and create a center line like this. Create a midpoint relation of with origin, and the diameter of the bush is 58. Okay, so let's make it 58. Okay, the tapping size is M8. Okay, so select hole wizard, tapped hole, M8. Okay, positions, and select these, through all. Okay, and cosmetic thread. Okay, now roll back to our cut extrude, and okay, this is done. Okay, let's save our bridge part. Okay, where is our bridge? Here it is. Let's make it float. Okay, let's uncheck instant 3D first. Okay, yeah, I have to make this here, create a circular mate. Okay, and the distance, there should be some distance mentioned of the bridge. There should be some distance. Okay, here it is. From this surface till this surface, it should be 112. Okay, so I will select distance mate here, input 112. Okay, now select this face and this face, click OK. Now we still have to add a relation. I will just create a front plane to front plane relation, so that this part is completely fixed now. Okay, let's I forgot to log the relation for the spindle. Okay, so here is the bridge. I still have to insert the bush here. Okay, I will just create a new part, bush for bridge. Top plane sketch. Okay, create a 58 mm. Okay, extrude it. The height here is 44. Okay, now select hole wizard, M8. Okay, select positions, this face, normal to, and select the quadrant points, click OK. Okay, you can see that it cannot create because of this. Okay, so to fix this we have a different method. Let me show you. First I will create this, let's say 80 mm. Okay, now on this face I will draw the pitch for the taps. Uh, 58 mm. Okay, now let's create the tapping here. Okay, now it can work perfectly. Okay, now create a extruded cut here. Okay, and keep in mind that this is the actual process. You cannot just create a 58 mm turning rod and then tap on it, create a tap on it. It is impossible, and not impossible, but it will be very costly. Okay, the best way is to create a road which is larger, like 80 mm, and then create the tap here, and then turn the piece here. Okay, uh, let's extrude cut it through all, flip side to cut. Okay, so now we have the threads and everything here. Save this part. I'm not going to create the thread here. I will show you how I'm going to do it. Let's go back to our assembly. Yes. Now select this push for bridge and this bridge here, and right click here, and there should be an option isolate, so that all the other parts are hidden. I will right click this and float it. Now let's create a relation between mates between these parts. Okay, this should work, and in the end you can just create a lock relation between these, so that despite, even if all the mates are removed now, these will always remain like this, locked with each other. Even in case, if you ask me, there will be some Loctite used to fix these bushes. Okay, so let's save this. Okay, but as you can see that this part doesn't have any internal threads. Okay, these internal threads, this bush still doesn't have. So how would I fix it? I will just edit this part. Now go to insert, feature, indent, and there is an indent tool. Okay, now this is our target body, and these are our threads here, and select cut here and click OK. Now right click push for bridge here, external references, click local. Okay, now when you open this part, you can see that there are threads cut here. Okay, you can see that this is not a problem, if you ask me. Okay, and let me show you here. If I check the cross section, these threads are perfectly aligned to each other. For example, if you are going to do a motion analysis and you don't need to add any screw mate, you can just use contact here, because there is a perfect precise contact here, okay, between these components. But keep in mind that the external references for this bush for bridge should be locked. Okay, let's save this part also. So we have nearly modeled every part here. Okay, you can see that there is nothing left here except these studs and these nuts. Okay, so let's work on these studs here. Okay, the stud here is 24, 28, 18. Okay, there is a M18 hex nut here, but if I'm right, SolidWorks doesn't have any M18 hex nuts. So let's first create M18 hex nuts. Okay, I will just open the SolidWorks and insert new part, M18 hex nut. I'm just creating this for a reference. I'm not going to design it completely. Okay, okay, so select top plane, sketch, polygon 6. Okay. Okay, I'm checking the design data book I have for dimensions, but it is also missing M18. So let's use some reference dimensions in between 16 and 20. Okay. Extrude it 9 mm. Let's make some cuts here like this. Extruded cut. Flip side to cut. The angle should be 60. Click OK. Repeat the same process here. I can just use this sketch and extrude cut. Select surface and select this surface. Reverse the direction, flip side to cut, and add the draft. Click OK. So basically I used a single sketch for two features, and you can see there is a hand a hand icon on this sketch. That means this sketch is shared between two features. Okay. Now let's make a cut here, M18. Extrude cut. Let's add cosmetic threads on it. I'm not sure if it has M18. It doesn't have M18 also. I will try changing the internal diameter and M18 into 1.5. It should be, wait a second. M18 has a 2.5 mm dia, so 15.5. okay. Sorry, 2.5 mm pitch. Okay, here is M18. So what I basically did here, I looked at the thread chart and the pitch. Let me show you. So let me show you the chart here, that will make more clear. You can see that for 18 the pitch here is 2.5. okay. So 18 minus 2.5 will be 15.5. So I changed the diameter here to 15.5 and the option for M18 was enabled. Okay. So we have modeled the M18 hex nut. I'm using cosmetic threads, but this is not a problem here. Cosmetic threads are not bad. They just save us some system resources. Okay. Unless you are in some bolt making industry, screw making industry, then it's bad to use these kind of threads. Okay. So we have created the M18 nut. M18 nut will be used here. Okay, 5 times here. Here also 4 times. So it will be basically 9 hex nuts. Okay. And here we have also a nut here. So let's make a nut here. This is 24 mm. Okay. I will go to design library, toolbox, add in now, ISO, nuts, hex nut, ISO 4034. okay. M24 cosmetic, perfect. Now let's create a mate here. Okay. Okay, this looks larger than this M18, but it's okay. We are using this only for reference, as I told, because I couldn't find the hex nut M18 size in my design book. Okay. Okay, but still this 9 mm looks very small, so let's make it 15. Okay. These parts come as a standard, so you cannot just use these. This will totally depend upon the availability in market. Okay. Let's hide these sketches, we don't need them anymore. Thank you, my sketches, you helped us a lot. These sketches actually helped us a lot in solving this drawing. Okay. Now let's create studs for these here. Okay. Let's first check the thickness. Thickness is 52. Okay. 52 plus, what is the thickness here? 15. 52 plus 15 will be 67, so we can use 70 mm stud here. So let's go back to our bolts and screws. There should be a stud. There are no studs here. Pins, in pins, do we have a stud? No. Let's check if we have some stud here. Set screw, no, not set screw. No self tapping. Okay, in case there are no studs, we can create it ourselves. It is not a big problem. I will just create a new part, M18 into 70 stud. Okay. I just have to create a cylinder here of 18 mm OD and 70 mm height, and I will just add cosmetic threads on it through. Okay, what did I did wrong here? M18. Okay. It should show M18 here. Okay, there is M18 through. Okay, so this will be our stud. I will just make this float, select this part, this cover plate, and this nut here, and isolate. Now let's create the mates here. Okay. Okay, there is some problem here. Let me just edit this feature and through all. Okay. Now the mate between this face and this face. Okay. You can think that there is interference, but let it be. It is not very important here. Okay. Now insert, copy with mates, this part also. Next, concentric here. Okay. Concentric here also, and coincident with this. Click OK. Let's repeat the same process here also. Copy with mates is a very good command. It helps us in reducing the time. Okay, I could have used circular pattern also, but somehow this looks more better to me. Okay. Let me show you how I could have done that. Let me just delete these parts. I could have just go to circular component pattern and selected this as my reference. These are my component to pattern, equal spacing 5 times. Click OK and done. This is actually more easier if you ask me, and keeps the this tree clean. Okay, now we have stud here also. Okay, from this till the inside of this. Okay, but let me measure the dimension from here till here. It is the distance is 146 mm. Okay, 146 plus we have to keep in mind that there is a tapping inside 25 mm. Okay, so let's create a stud here, keeping in that mind. You can see that there is a pillar stud here. Okay, a stud with pillar, but I'm going to use simple. Okay, or let's just create a stud here, keeping that in mind. I'm 18 into 146 plus 25, 1670, so it will be around 170. Okay, I'm 18 into 170 stud. Okay, let's open this part. Create a center line. I'm just drawing some reference. Okay, these are actually collinear to each other, and these are collinear to each other and equal. This is 25 mm, little less than 25 if you ask me, but let's just use 25 mm here. Let's make this color 5 mm. This is 8 mm, 18, sorry. The complete length is 170. And now this length here. Okay, the length of this line, it will depend upon the tapping here. Okay, this is 34 plus around 15, it will be around 50 mm. Okay, so let's make this 50. Okay, rather than using this 50 here, let me show you what is more important here. Okay, the distance between this face and this face. Okay, the normal distance is 112 mm. Okay, now this is important. Let me show you how. This 112 mm is between these faces, if you ask me. So I will just use that as reference. Everything looks fully defined. I'm just stopping so that you can see this sketch clearly. The distance between the faces, I used 1112 here because the faces will be mated on these lines. Okay, these faces. Now let's add cosmetic threads here up to next M18. Let's repeat the same process here. Okay, let's add some fillet here so that it looks like the one in drawing. I will select this part and this stud, right click, isolate. Let's make this float. Okay, now mate, select this face and this here, this face and this here. Okay, click OK. Okay, copy with mates. Okay, let's exit the isolate and okay, this is a little shorter. You can see it should it should come out of this. Okay, so let's make this wait a second. Okay, this is not flipped. I was afraid that it was flipped. Okay, so let's add some dimension in this. Okay, this 170 plus let's say 15 mm. Okay, we still have to increase it if I'm right. Device 14. Okay, where is our M18 hex nut? I will just drag it here. Let's mate this part. Okay, it's still small. Let's increase the length again. 190. Okay, this looks nice. Okay, this looks okay. Let's copy this part here. Coincident on this face and concentric about this. Okay. Okay, now about this part. You can see that there is a M8 tapping here. We have to add something, some bolt here also. Let's use grub screws here. Okay, so M8 into 44 mm grub screw. We can use 40 mm also. Okay, let's see where is our grub screw. Set screw slotted. We can use these also. Set screw socket. Okay, 4029. This is 4027. Okay, this one. Okay, M8 into 40 is the length here, so 40 is okay. Cosmetic, click OK. Mate this part here, reverse the direction. Let's hide this sketch here. Copy with mates. concentric, coincident, exit the isolate. Let's save our assembly because we don't know when SolidWorks can crash. Okay. So we have created the studs for this portion here. We still have to do it here. Okay. So let's do it here. The length is normal distance is 102, and okay, let's create another stud here. M18 into let's calculate it again. Sometime I'm not sure. Okay, 136 plus the height here we needed to compensate. 136 plus 20, 156, 155. Okay, 155 plus 25 will be 180. Let's create our stud here. I will again draw a line like this. Let's draw a sketch like this. Okay, the length here is 180 mm. It is a M18. Let's make these collinear. This let's make 22, 23, doesn't matter much. You can make it 25. Okay, we still have to figure out the upper dimension. Okay, the distance between the faces we still have to figure out. Let's measure it. The distance between these faces. Okay, 102 mm. Now revolve this part, add cosmetic threads, okay, let's repeat the same process for the lower cylindrical part. Let's head back to our assembly. Okay, first let's save this part. Okay, I will check if any other unsaved part. Here it is. Okay, now select this cover plate and the stud we just created. Right click on this and isolate. Make this float and let's create mates. Okay, this face and this face. Repeat the same process for the other one. Let's add fillets here. 5 mm. Okay. Yes. Exit isolate. Okay. You can see that there is very small gap here. So I'm not sure if M18 hex nut will fix here, but let's see. Coincident on this face and concentric about this. Okay, there is an interference. But these kind of problems are actually fixed during the during the production and trial. Okay. You can just reduce this. You can increase this radius. The radius here. Okay. You can increase this radius, or during the machining process they will just cut extra material here, something here. Okay, to fix this problem. So let me check if anything is left or everything is done here. Okay, let me check. Okay, all the parts are done here. Let me check. Okay, everything here is done. Okay, now the part is the motion where we try to move it. Okay, so that this actually this steam stop wall open, this will go up. Okay, now for that it will take some time, and in next video I will show you how to create a animation for this. Actually, animation is not very important in this part. We just have to apply a motor and move this rotate this hand wheel a couple of times, and it will open up. Okay, but for now, if I'm right, this video is already 2.5 hour, around 2 hour or 2.5 hour long, and it has already been, this video is already too long. I don't think a lot of people will waste their time watching this. And if you liked this video, please give me a like, and click subscribe to my channel so that you can receive more updates from my channel, and share it with your friends. If you are a student, engineering student, or some graduate, if you are a hobbyist, and if you had any problem with this drawing at any step, you can ask me. I have separate drawing, and if you want the drawing for this part, you can visit my blog cadguild.blogspot.com, or you can just follow the links to our Facebook page or WhatsApp group in the description of this video. Okay, thank you for watching this video tutorial, and have a nice day. One more thing, if you want the model of this file, you can also download it from our blog. Okay.